All right, geometry. So for today, what we're going to be jumping into is we're going to be jumping into a little bit of trigonometry. And trigonometry is actually going to help us in geometry to actually find the missing side lengths of a right triangle. And it actually uses similarity to find that. So we've been doing all this stuff with similar triangles. So now it leads into that. So the first thing I like to talk about is a little bit of trig ratios and how to solve for those. So the first thing we're going to look at is I have two right triangles that are 30, 60, 90 right triangles. So we have a 90 degree, a 30 degree, this would be 60, a 90 degree, a 30 degree, and this would be 60. So I already know that these two triangles are similar to each other. So I could set up proportions and solve for missing side lengths if I wanted to. But what I'm gonna do today is I'm gonna show you how trig ratios work. And more specifically, we're just only gonna look at the tangent ratio. So the first thing we're gonna talk about is anytime that you're dealing with trig, you're gonna be dealing with a reference angle. And whenever a reference angle is never going to be the 90 degree angle, it's always going to be the other two angles. So given a reference angle, we need to name the sides based off of that angle. So automatically, we already know that opposite of my 90 degree is always going to be my hypotenuse. Opposite the 90 degree is always going to be my hypotenuse. That's with any right triangle. We automatically know that. Now, based off of my angle, which is my reference angle, we need to name the other sides based off of that. So 30 degrees is my reference angle. So starting at 30, if I go to the other side of the triangle, this is going to be known as my opposite side. And then my third side that I have not listed yet is going to be known as my adjacent side. Now I'm going to do the same thing with the other triangle. This is my reference angle. I'm going to go all the way to the other side of the triangle. That's going to be the opposite side. And then the other side length is going to be my adjacent side length. So we're going to name those based off that. Now, just to let you know, I'm coming up with these numbers to show you how this works. So right now, in this 30, 60, 90 right triangle, let's call this number 2. So that means the hypotenuse would then be 4, because I'm going to multiply times 2. And the adjacent side would be 2 square root 3, okay? Now I'm gonna do the same thing with this side, but I'm gonna scale it up by 4. So that means this would be 8, that means this would be 16, and that means this would be 8 square root 3. So what I'm gonna do now is I'm gonna talk about something called a tangent ratio. Whenever you write the word tangent, when you think of your ratios, when you write the word tangent, tangent is always going to be the opposite side over the adjacent side. So right now, would you agree that this triangle is smaller than that triangle? But whenever I do the tangent ratio, which is going to be opposite over adjacent, those ratios are actually going to come out to be the same. So right now, my opposite side of this triangle is 2. My adjacent side of this triangle is 2 square root 3. So I'm going to do opposite over adjacent. I'm going to do the same thing with this triangle. I'm going to do the opposite over the adjacent. So right now, opposite over the adjacent. So 8 square root 3. So now if I was to actually simplify both of these, this would actually simplify. The 2's would cancel, which would give me 1 over square root 3. And the 8's would cancel, which would give me 1 over square root 3. So if you look, these two ratios are actually the same. Now let me go ahead and do this and figure out what 1 divided by the square root of 3 is. And 1 divided by the square root of 3 is going to be 0.577. So both of these are going to be the same. They use the same exact thing. So across the board, those ratios are going to be the same. Now, if you look, both of these angles are exactly the same. So I know that tangent of any triangle, so if I was to make another triangle with a 30 degree angle and I was to do the opposite over the adjacent, this is what the tangent of 30 degrees is going to be. So if you go in the calculator and you type in the tangent, so tan means tangent, and I type in 30, the tangent of 30, and I clicked enter, it would end up giving you 0.577. So we're going to end up using that to find a missing side length, because I know anytime I do the opposite over the adjacent of a 30 degree angle, this is going to be the value of that ratio. So I can use that to end up solving for a missing side. So if I set this equal to that and solve for a missing side, I can use that to find a proportion and set up. So now, down below on the bottom of your paper, I'm going to show you how to use the tangent ratio. That's what we're using today, is the tangent ratio. So here we go. Let's look at our example. So right now, looking at the example on the bottom, we need to find the value of V, okay? I have been given a 60-degree angle. So this is going to be my reference angle right here. So now I need to label the side lengths based off of that reference angle. So opposite of my 90-degree angle is always going to be the hypotenuse. You need to label that. Opposite of my reference angle is going to be the opposite side. And then obviously my third side length is going to be my adjacent side. So right now, if you look, I have my adjacent side and I need my opposite side. Where I told you guys a while ago that the tangent ratio is known as the opposite side over the adjacent side. So right now I can actually figure out that ratio and I can go ahead and solve for this. So right now I know I'm using the tangent ratio of the 60-degree angle. So I know if I typed in the tangent of 60 and clicked enter, it would give me a decimal like it did earlier. Well, if I actually knew this value of this opposite side, and I know this value of the adjacent side, and I was to find that ratio, the tangent of 60 and that ratio would be equal to each other. So I can set up an equation and solve. So I'm going to do the tangent of 60, and I'm going to set that equal to the opposite side, which is V, over the adjacent side, which is A. Again, I'm going to re-clarify. If I knew what the value of V was, and I plugged that into here, and I click divide, those two ratios right now would be the same. These would be the same exact thing. So that's how I can use it to solve for that missing side length. So right now, I am dividing 8 away from V, so I'm going to multiply by 8 on both sides. So right now in your calculator, you're going to do the tangent of 60 times 8. And that's actually going to give you the value of V. So if I go to, you can go to Desmos as well and do this. I'm going to go tangent of 60, and I'm going to multiply that by 8, which is going to give me roughly 13.86 is going to be the value. So I had to round there, but if I did 13.86 divided by 8, it would actually give me the decimal of tangent of 60, okay? So right now on the back side of your paper, I'm going to work one more example, and then I want you to go do the other two. Okay, so here we go. Look on the back side of your paper. All right, so right now I need to find the value of V. Okay, so 30 degrees is my reference angle, so I need to label this. So this right here is going to be my opposite side. This right here is going to be my hypotenuse, because opposite the 90 is always the hypotenuse. And then the V is going to be my adjacent side here, okay? So right now, I am going to be using opposite and adjacent. So that's going to be my tangent side. So right now, I need to do the tangent of 30 degrees, which I know if I did the tangent of 30, that would give me that 0.577 that I got at the beginning. And then I'm going to set that equal to the opposite side, which is 2, over the adjacent side, which is V. Now, if I knew what the value of V was, and I clicked enter and divided those, then these two would end up being equal. Because if I type this in the calculator, that's going to give me a decimal. Okay? So right now, in order for me to solve for this, I know that I would multiply by V on both sides. So I'm going to multiply by V on both sides. So that's going to end up canceling over here. So all this is going to go away. Now, to get V by itself, I'm going to divide by the tangent of 30 on both sides, because I know the tangent of 30 is an actual number. When I divide that on both sides, that's going to cancel, and it's going to give me V. Now, if you notice, when your variable's on bottom, the left side and that denominator basically just switch places. So anytime your denominator's on the bottom, or your variable's on the denominator, just flip those places. Now, if I go type this in the calculator, that's going to end up giving me that value. So I'm going to do 2 divided by the tangent of 30 and click enter. So I'm gonna get roughly 3.46 is my number. So right now what I need you to do is I need you to try the two examples down low, see if you get your answer, go check it with your buddies, and then you're gonna have an assignment to do in Schoology. Let me know if you have any questions.